I'm Thomas Smith. I'm the CEO of Gado Images. We are an AI-driven content agency based out of San Francisco, and we've been using AI in various capacities to help with annotating images for many years now. But we've been, just in the last couple of months, trying a new process that's built on using GPT-4 as part of our captioning process. And we've been really happy with the results. So I want to show you first some of what this can do. This is fully automated captioning using AI. And then at the end, I'll show you some of the technical side of how this works. So firstly, these are some images that we've just recently taken. We are a full photography agency, so we have people out in the field shooting images. And what we did is we actually just ran these through our new software that, again, is based on GPT-4, and this is the raw results. We didn't edit anything here. This is literally, for titles and descriptions, exactly what the software churns out, with no supervision, no human in the loop, it's sort of a zero shot type of result. And you can see for some of these it's quite impressive. So this is a field of yellow flowers near Lafayette Community Center with trees in the background, Lafayette, California. Indeed, that's exactly what this is. This is a wildflower field taken at the Lafayette Community Center, Lafayette, California. It's generated an appropriate title for each of these. So this is the Lafayette Blooms, Lafayette Center Flora. That's pretty good. It even got that this is a tree tag. It's not blue exactly, it's white, but a blue tree tag attached to its trunk. Overall, pretty good that it got that this little circle is a tree tag. And again, these are editable, so if I was actually going to do that, I would just say a tree tag, and that would be an updated caption now. It does work on a variety of different things. It detects logos and company names. So here we have EV charging station with charge point logo and signage at target location. This part is not correct, featuring a phone displaying charging information. I think it thought this was a phone. It's actually part of the charging station. Again, a pretty simple fix to that caption. Surrounded by plants, San Ramon, California. Really pretty impressive what it can get. Indeed, this is at Target. That's not even obvious from the visuals of the photo, but it's important from an editorial captioning perspective to know where exactly this is located. It got the charge point, it got what this is, that it's an EV charging station, so pretty good. Penske truck rental van parked in front of a building with signage and logo, Commerce Avenue, Concord, California. That's pretty much perfect. Electric vehicle charging station with AD accessible sign, 2-hour limit, and a parking lot surrounded by trees. That's pretty accurate. You don't actually see the charging station in this photo. It's more the sign for the charging stations. That might need to be clarified. Volta charging station with vehicle at the Veranda Shopping Center, sunny sky backdrop, Concord, California. I think it's imagining a vehicle, which isn't there, but again, pretty good. This is indeed at the Veranda charging station. It's getting that just based on the Veranda Shopping Center. It's getting that just based on the logo and what it's seeing in here. Gap Factory storefront with visible signage surrounded by plants and clear sky, located in the Veranda Shopping Center, Concord, California. Pretty good. I think it tends to talk about plants too much is one weird thing we've noticed. If there's plants in the shot, it's going to talk about those plants even if they're not especially relevant. So that's something we might want to tamp down, surrounded by trees, that there's plants here. Not always relevant to the caption. One thing it's not as good at this point is captioning stuff that's sort of one object, a generic object. It's pretty good at locations and logos and that kind of thing. But like this should just be something like challah bread on a plate. And we get that it's challah, so it knows what it is, but it sort of gets like close of a pastry on a plate, surrounded by tableware, ingredients like challah. This should really be tuned. So I don't think it's as good at handling single objects like that or generic objects as it is at handling more of the editorial style. And I think that's just because most of our collection is editorial. It's based on locations, it's based on brands and that kind of thing. So there's just not so much training data on single objects. We can keep going with this. Electric car charging station, a charge point station. You can see we did a series on EV chargers. Uncle U's and Citizen Salon. Those are the stores in the background. Maybe not so relevant to include both of the stores, but overall pretty good. You can keep going past some of these. Generic street views, it did a pretty good job. This is just basically Lafayette. This is just a generic Lafayette, California street view. It does a pretty good job of talking about the city and what we're seeing in this. I thought this was an interesting one. COVID test. It got that it's an antigen test. I don't know where it got the price of $13. And it's not electric blue or composite material. So again, single objects it's not as great at, but more of these sort of scenes and editorial types of things it does very well. So overall, we've been really happy with the results from this, and I'll show a little bit on the technical side of how this is working. So basically, this is a combination of a GPT-driven process and also some underlying AI models. So the first thing is we take the image, we run it through a bunch of different lower level models. We do OCR, which pulls any text out of the image, logo detection and landmark detection. So these are any corporate logos. Landmark is more like locations. So if you've got like the Golden Gate Bridge, it'll pick that up from the visuals. Object tagging, so that's tagging objects like, again, the plants you keep seeing, but cars or the challah bread or whatever that's in the image. Again, a pretty low level model that's just giving us back tags. GPS location data, this is pulling in the embedded GPS data from the phone and doing a reverse geolocation search, which is how we get the cities and that kind of thing that it uses in the captions. And then a visual AI system. So this is a little higher level, but it's not quite at the level of a transformer. It's just trying to look and kind of create a one sentence, almost like alt text description of the content of the image. And this is using, in this case, an off-the-shelf locally run model that's able to do that. It's an open source model actually from Salesforce. It's based on the Blip2 model. So this is giving us almost like a very simple visual description. That helps it, I think, to interpret how the objects and logos and things that it's detected fit together. All of that data then goes into a large language model. In this case, it's GPT-4. This is not seeing the images. We'll get to that in a second. It doesn't have any visual input to this model. It's only text input. And it's using that along with existing captions. So this is our training data. Again, it's sort of biasing it towards the images we tend to take, which is more of those sort of, again, editorial types of images. It's taking in our existing captions, taking in our own custom prompting that tells the model what we want and examples and that kind of thing. And then it's spitting out the titles and descriptions that you're seeing, which again, we're pretty happy with what it's able to do with no supervision. It's sort of a zero shot type of thing. They're not all perfect. This one in particular sort of missed the mark. A Pacific Aerospace vehicle. It's actually the logo on the back of a Chrysler Pacifica. But generally overall, pretty good results. To actually finish using these, if we want to use them for a production process, obviously we'd put a human in the loop to review and correct, as you saw me doing there, and then we'd have our final captions out of it. But you can see that with a lot of these images, it gets you either 100% of the way there in some cases, or maybe 80 or 90% of the way there. Some future things, we'd love to train it with to do a better job at handling those images that are single objects. It's not so great at that yet. It's more for those editorial images, more context. And also, we'd love to integrate a multimodal large language model so that the LLM wasn't just taking in the text from the underlying models, it was also taking in the image itself. And I think that's where GPT-4 will eventually take us, and it may replace this whole step, or at least augment this step, if the LLM can actually process the image and not just the text about the image and the metadata gathered from these lower level models. That said, it might still work fine or work better to have this handled by the lower level models and the LLM just creating the caption. It certainly might be less resource intensive and less expensive to do it that way, depending on the pricing for using an LLM that's multimodal and can take in the images. We'll see as that develops. In any event, that technology is not there yet, so this is the approach we've taken so far. Very exciting. We're very happy to see where it's going. Obviously, it's not there yet, but we're excited about the progress and how we can build this into our own processes. If you have questions, feel free to email me. It's tom@gadoimages.com, or find me on Twitter @tomsmith585.